Hi everyone. In this time I discuss about very most important topic. This topic is isomorphisms theorems for rings. Okay, isomorphisms theorems for ring. The first theorem it is if B R and S. Okay, R and S be two rings. It is if such that R to S. Okay, R S. Okay, it is if such that R to S be a epimorphisms with kernel K, epimorphisms with kernel K. Okay, then the ring S is isomorphic to the factor ring R by K. Okay, to the factor ring R by K. In the other words, if F be a homomorphisms, in the other words, if F be a homomorphisms of a ring R. Okay, and next into onto a ring S. Okay, onto a ring S with kernel K. Okay, with kernel K. Okay, with kernel K, then R by K, then R by K. Okay, and S are isomorphics. It is also known as fundamental theorem of ring homomorphisms. I repeat this topic. Okay, please you understand. If R and S be a ring and if such that R to S be an epimorphisms with kernel K, then the ring S is isomorphic to the factor ring R by K. In the other words, if F be a homomorphisms of a ring R onto a ring S with kernel K, then R by K and S are isomorphics. It is known as fundamental theorem of rings homomorphisms. Okay, next second theorem, if S be a subring of a ring. Okay, S be a subring of a ring R and I. Okay, subring, it is if S be a subring of a ring R and I, be an ideal of R, be an ideal. Okay, ideal of R, ideal of R. Okay, ideal of R, then the factor rings S plus I, then the factor ring S plus I. Okay, by I. Okay, and S by I intersection S. Okay, this topic and this topic please you remember. Okay, S plus I by I and S by I intersection S. Okay, are isomorphics. Here we define G such that S tends to S plus I. S plus I. Okay, S plus I by I. S plus I by I. Okay, and by Gx is equal to x plus I. Gx is equal to x plus I, and x belongs to S. X belongs to S. Okay, so that G is an epimorphism if K be the kernel of G, then by the first isomorphism theorem S by K, then the first. Okay, then by the first isomorphism theorem S by K. Okay, S by K. Okay, S by K, it is isomorphisms to S plus I, to isomorphisms S plus I by I. S plus I by I, since curve G is an ideal of S and K is equal to I intersection S, I intersection S. Okay, and hence the theorem, okay, follows. I repeat this topic. Second theorem, it is if if S be a subring of a ring R and I be an ideal of R, then the factor rings S plus I by I and S by I intersection S are isomorphic. Next, here we define G such that x s tends to x s plus I by G x is equal to x plus I, x belongs to S. Okay, so that G is an epimorphism. If K be the kernel of G, then by the first isomorphism theorem, S by K is isomorphic to S plus I by I since car G is an ideal of S. So K is equal to I intersection S, and hence the theorem follows. Next I talk about third theorem. Okay. Third theorem, if I and J, okay, if I and J, okay, I and J be two ideal of a ring are with J subset I, okay, J subset I, then I by J is an ideal of ring. Okay, then I by J is an ideal of ring R by J. Okay, ideal of ring R by J. Okay, and R by J and R by J by I by J. Then I by J is isomorphic to R by I. Okay, J cancel and R by I. You understand? This is very most important topic. This is isomorphism theorem for rings. Okay. I provide this PDF. Okay. You understand? Isomorphisms theorems for ring. Okay. First theorem: if R and S be two rings and F such that R tends to S be an epimorphisms with kernel K, then the ring S is isomorphic to the factor ring in G. Okay, ring R by K. Okay. In the other words, if F be a homomorphisms of a rings R one to a ring S with kernel K, then R by K and S are isomorphics. Next, it is also known as fundamental theorem of ring homomorphisms. Second theorem: if S be a S union B ring of a ring R and I be an ideal of R, then the factor ring S plus I by I and S by I intersection S are isomorphics. Here we define S such that S tends to S plus I by G x is equal to x plus I. X belongs to S, so that G is an epimorphisms. Epimorphisms if K be the kernel of G, then by the first isomorphisms theorem S by K is homomorphic to S plus I by I since G is an ideal of S. So K is equal to I intersection S, and hence the theorem follows. Next, third theorem. Okay, if I and J be two ideal of a rings are with J subset I. Okay, then it is I. Let's remember I. Okay, and next, then I by J is an ideal of R by J, and R by J is isomorphic to R by J.